What I want to move on to now is what happens if I want to find, say, the angle between two vectors. Okay, so I have two vectors here. I'm going to call this one A, okay, and I'm going to call this one B. And what I'm after is the angle which occurs between these two vectors. So let's call that angle theta. Okay. Now that angle, you notice, is caused when the start of A meets the start of B. So I'm putting the two starts together like that. Okay, and they're shooting off in different directions. So this is different from adding them together, because adding them together would be taking this vector and joining it to the end of this vector. So start to finish. Yeah? So what I'm after is this. What I'm after is this. How could I do this? Has anybody got any ideas? Okay, so let's form a triangle. That's a really good idea. So let's form a triangle. So let's join this to this, and let's form a vector, because we're working with vectors here. So let's form that vector there. Now, what would that vector be? What would that vector be?
It's two vectors, A and this vector you add, and the B is a distance.
Okay, so you're trying to use A and B, because at the moment I've got no clue about what that vector is, okay, unless I give it another name. So what I'm going to try and do is I'm going to try and get from this point to this point using vectors that I already know. I know what A and B is. I know those two vectors. Could I find this vector here in terms of A and B?
A, B minus A will be this vector.
Good, okay, so you're saying, right, I know, I could go from here to here by travelling backwards along A. So I could go minus A. Yeah? Now if I'm here, I want to end up over here, so what could I do? Move forwards along B plus B, good. Would you be happy with that? So that's how I could describe this vector here, because it's a movement from this point to this point. It doesn't matter how I get between those 2 points, as long as I get between those 2 points. So this I could also write, just because it's a little bit neater, as B minus A. Are you happy I've just switched those two things around because they are just addition? Okay. Right, so let me get rid of that then. So remember, what I'm after is this thing here. Okay. Now you're happy this is just a general, non-kind of right-angled triangle. So you remember, I know a rule to find out this angle here using any of the rules which I used in the last theme. Okay. So if I call this, say, angle, I don't know, call this angle A, this would be side A, in which case these two sides would be B and C. So how could I find angle A in that case? Yeah, good. So it's the cosine rule. Now, just because it's a little bit more generic, and I think it will fall out a little bit nicer, I'm going to do it in terms of a side, even though I'm trying to find an angle, but you'll see why in just a second. So I'm going to take A, and I'm going to square it, and that should be equal to what?
B squared plus C minus 2
Of the angle corresponding to the side which you want to find. Yeah, so if that's A, that's also got to be A as well. Okay, that's just the cosine rule. That's just the cosine rule. So therefore, I should be able to use that in here. Issue though, what are A, B, and C corresponding to? So A is a length. It's not a vector. It's not a movement. Is that okay? So it means that if I'm going to use the cosine rule over here, I need lengths, not vectors. So in other words, I need the length of B, the length of A, and the length of B minus A. That's not an issue. All I have to do is just put length there. Okay, so I'm going to use the lengths of each of those things. Let's do this. The cosine rule says that I should take this length here, which is B minus A, and I should square it. Okay, I should square it. And that should be equal to B squared. Well, remember, it doesn't matter what I call these two sides, so I'm just going to keep it consistent. I'm going to call that one B squared. I'm going to call that one effectively C squared, right? So modulus of A all squared. The length of that vector there, all squared. Okay? And then I should take away 2 lots of the length of this vector here times by the length of this vector here. And then I should times that by the cosine of the angle between those two vectors, which I've just happened to call theta. So cosine of theta. Okay. Now, at the moment, I can't really do much with this, but let's think about this. It's using something called the dot product. Now, what dot product is, it's a way of multiplying two vectors together. There's two ways of multiplying vectors together. We will only look at one in this course, and it's something called the dot product. So if I just write it up here, if I take just a generic vector, let's call it u, okay? And let's suppose that u just has an x component and a y component. Let's just call it u1 and u2, okay? So if I dot product this, what this literally means is that u dotted with itself, okay, so just two vectors multiplied together, I'm just choosing to use u twice, like why not? What this literally means is that I just multiply the corresponding elements together and then add them, okay? So I take u1 and I multiply it with the corresponding x component, which in this case is just u1, okay? Then I should add that to u2 times by itself. So u2 multiplied by u2, okay? So, okay, u1 times by itself would just be u1 squared. And u2 times by itself would just be u2 squared. Okay, now have a think. This should look familiar. Because, for example, if I wanted to find the length of u, what would that be equal to? It's just x component squared plus y component squared, then square rooted, okay? So if I square it, would you be happy that that would be equal to the x component squared plus the y component squared? That should be the same, shouldn't it? Like the length of u will just be u1 squared plus u2 squared square rooted. So therefore, if I square both sides, I should get modulus of u squared should be equal to u1 squared plus u2 squared. So what I have proved there is that modulus of u squared should just be equal to u dot u. Okay, so the dot product of u, right? Which means that when I come down here, what this should literally be is the dot product of b minus a with itself. And that should be equal to, that's just the dot product of b. So b dotted with b. And that's just the dot product of a, yeah? So a dot a, and then these I can't really do much with at the moment. All right, fine. It's just a case of expanding that out. Now this is just literally that times that, minus that times that, minus that times that, minus a times negative a, which makes positive a squared. So therefore I should get b dot b, it's just expanding it out just like a wooden ordinary quadratic, minus 2ab plus a dot a. And that should be equal to b dot b plus a dot a minus 2 modulus of b modulus of a cosine of the angle between them. Okay? And I can do a bit of cancellation here, just finish it off. So that cancels with that cancels with that negative 2 cancels with that negative 2. So therefore I'm left with a dot b should be equal to modulus of a modulus of b times by the cosine of the angle between them. Or if I wanted it more generally, because I want to find that angle there, I just divide by the modulus of those two things. So I could say that cosine of theta should be equal to a dot b divided by the modulus of a modulus of b. Okay? That is how I find the angle of between two vectors. That's how I find the angle between two vectors. That's a proof. You don't need to know these steps, but you do need to know that.